I'll take notes, and I'm sure someone will kind of step up with me to working code EMD as well. No worries.
Great, thanks. So yeah, let's get started. Joe Salloway, one of the chairs, and my co-chair Mohit is also on. And this is the EMU meeting for the virtual IETF 109. So there's a couple links here. I think probably by this time in the week, you're pretty experienced with dealing with the virtual meeting tools. But here's some info. But what you're probably really all waiting for is the favorite Note Well. Again, you're probably all familiar with this, but if you're not, please familiarize yourself with the IETF's IPR policies. All right, so we have a pretty full agenda. I think we'll have enough time for it this time, but because we ran out of time last time, we did give priority to some of the presentations that we were unable to get to in at the last virtual meeting. We have note takers. The blue sheets are taken automatically. We have people monitoring Jabber. So is there any bashing of the agenda that we'd like to do? I mean, we have TLS proof of knowledge from either Owen or Dan will present, I'm not sure which. And we have TLS IBS. We'll go through some of the TIPA errata. Hopefully that will not take the whole time, but hopefully we can have some good discussion on that. An update for EAP Noob, and then a new presentation on EAP Ad Hoc. Any other topics people want to go through? All right. So I don't know, Mohit, did you want to talk through some of the draft status or?
Morning, can you hear me?
Yes.
Yeah, so I will be presenting a short update on EAP Noob, so we'll deal with that during the agenda today. I think Yari submitted an update of EAP aka PFS. I don't know if Yari wants to say something, but it looks more or less ready. I guess if Yari is on the I don't know if he's in the meeting and wants to say something. Then we had this large certificates, which was approved by the IESG, but pending a document update, and I submitted an update yesterday. So now it's, I guess, with you, Roman, to, I guess, send it to the RFC editor.
Yeah, I'll take a look, and then yeah, assuming it's fine, we'll keep it moving.
Sounds good. Using EAP TLS with TLS 1.3 is scheduled for the IESG telechat on 17th of December. We got like a couple of emails from IANA that we need to clarify the TLS exporter labels that we are registering, if it's okay with DTLS and whether it's recommended. So I plan to add those information to the IANA section and submit a new version hopefully today. But I guess more importantly, we are waiting for a review from Hannes. He had promised that he will go over the document once more. And thank you, Hannes, already for sending the reviews thus far. So yeah, then EAP TLS with TLS 1.3 hopefully will be done by December. EAP, aka the 5448 BIS document, is pending some synchronization with 3GPP, so we'll wait for that. I think Yari and Vesa, who are co-authors, are also like discussing this in 3GPP and basically figuring out how to ensure that both the document here in the IETF and the specs in 3GPP are completely in sync and don't leave something to be misunderstood. So we wait for a document update on that too. And yeah, we had our first RFC published between 108 and 109, which was RFC 8940. And thanks to Alan for doing the work. Yeah, I guess that's the status unless someone has some more updates.
I think Hannes is in the queue.
Yeah, hi Joe, hi Mohit. Yeah, I've started doing the review already. This week was a little bit busy, but yeah, thanks for the updates, Mohit. I definitely much better. The document is much better now. I think from a readability point of view, so there are only maybe nits here and there, but nothing really substantial.
Yeah, thanks, and look forward to the next review. So just FYI, the document is on the telechat for 17th. So if we can get it before that, that would be nice. But your reviews are welcome at any point, even when it's in the RFC editor's queue. So
no, I try to deliver them in a timely fashion.
I guess we are done with the status update.
Great. So I think we'll move on to our to either who's going to present? Is it going to be Owen or Dan? For
it's going to be Owen.
all right.
Joe, will it be easier if I just share and I can move on the slides as I'm going?
You can if you want. That'd be fine.
I'm in the queue for a screen share.
All right, let me see let me stop this one. Are you able to, there we go.
Yeah. Okay, people seeing my share now?
Yes.
Yeah, perfect. Okay, so this is TLS Proof of Knowledge. Myself and Dan, I'll just give you some background context first on the Wi-Fi Alliance device provisioning profile. So what Wi-Fi Alliance DPP does, it defines how a supplicant's Bootstrap key pair can be used to bootstrap the supplicant security against a Wi-Fi network. DPP gives the supplicant a guarantee that it's connecting to a network that knows its Bootstrap public key. And just some information on what this Bootstrap public key is. It's encoded using a RFC 5280 sublet public key info. It's a raw key pair. It doesn't necessarily have to be part of a PKI. It may be static, embedded in the supplicant firmware, printed on. It may be delivered via printing on a QR label, included in a bill of materials, etc. Or alternatively, the Bootstrap key may be dynamically generated and displayed on a GUI if your device that you're trying to bootstrap has a suitable display. We want to reuse the same Bootstrap public key to enable a device to securely bootstrap against a wired network using ETLS via TLS extension. And what this means from a deployment perspective is that if a device supports both Wi-Fi and wired networks, the same QR code, the same BOM, etc., may be used to establish trust across both Wi-Fi and wired networks. And just at the very bottom there, I've given an example of the ASN1 encoding of a subject public key and what that looks like in QR, and this is all defined in the DPP spec. So just a quick, again, more context. It's a quick outline of what DPP looks like and what the protocol, what shape the protocol has. The public bootstrap key, step one, the public bootstrap key is provisioned in an entity that's called a DPP configurator. So typically this could be a mobile app, or alternatively the configurator could be embedded into the Wi-Fi access point. And proof of knowledge is carried out via Diffie-Hellman exchange between the configurator and the supplicant. It uses the bootstrap key of the supplicant, and the configurator generates an ephemeral Diffie-Hellman key as well. The supplicant proves it knows the private key of the bootstrap key pair, and the configurator proves that it knows the public key of the bootstrap key pair. And then a secure channel is established. Step 3, network information is securely exchanged. And then step 4, the supplicant attaches to the network. So in summary, the configurator and the supplicant establish a secure handshake where the configurator proves to the supplicant that it knows the supplicant's Bootstrap public key. The supplicant proves it knows the private key. Once that secure channel is established, the configurator imprints the supplicant with network information and network credentials, and then the supplicant will attach to the network. And so what we want to do for wired LAN is the public key of the Bootstrap key is scanned into the network and known by your AAA or your ETLS server. The device wants the network to prove that it knows the Bootstrap public key before the device will connect to the network. And this can be quite easily achieved by making a simple extension to the TLS handshake. And what we do in the TLS handshake is we exchange 2 sets of Diffie-Hellman keys in the client hello and server hello. So the first key share is just a standard key share for in TLS 1.3 Diffie-Hellman, where both sides generate ephemeral key pairs and exchange them. And in step 2, we add a Bootstrap extension where the client sends a hash of its public key to the server, and the server uses that hash of the public key to look up the raw public key. The server generates its ephemeral key pair, and then the 2 sides can complete that second Diffie-Hellman exchange. So both Diffie-Hellman calculations are injected into the key schedule using the mechanisms outlined in the draft of reference there. There's also the alternative draft, which is referenced in our document, the hybrid design draft. So there's multiple ways of figuring out how to inject that second piece of information into the key schedule. But what we've implemented at the moment is the Highland one. So these are extracts from the draft. It shows you the shape of the Bootstrap key extension, and that extension can be sent in either a client hello or a server hello. In a client hello, it's just a hashed reference to the public key, so that allows the server to look up the public key. Unlike a standard key exchange, you're not setting the full raw public key, you're setting a hashed representation which allows the server to look up the public key. And in the server hello, the server is exchanging their ephemeral Diffie-Hellman key, their second ephemeral Diffie-Hellman key, alongside the standard key exchange. So you can see that illustrated in the call flow in the bottom left. The client sends the Bootstrap key in its client hello. The server sends back its corresponding Bootstrap ephemeral key in its server hello, in addition to the standard key shares. And the graphic on the right-hand side shows you the mechanism taken from the Highland draft for injecting a second input into the key schedule. The BSK input is just the second Diffie-Hellman that takes place, and we're injecting it using the mechanism defined in that other draft. So what this means for an operator perspective is everyone is happy. If you have a device that you're trying to onboard, the device has an associated Bootstrap key, which could be embedded in the firmware, dynamically generated on a label, whatever. That QR code is scanned into the network, and regardless of whether you're connecting the device via wired using DPP or via wireless using DPP or via wired using this proposed TLS extension inside an EAP, and you're able to securely authenticate the network. Security considerations: it leverages the TLS handshake, and we're not defining any new esoteric cryptography. All of the existing TLS security proofs should still be applicable. The security proofs that will be defined, and they're touched on in the Highland draft, but they're not fully fleshed out, should handle the key schedule changes as well, so we shouldn't have any work to do there. And in terms of Bootstrap key security, TLS proof of concept has exactly the same security stance as the Wi-Fi Alliance DPP with respect to those Bootstrap keys. So for DPP, if you know the Bootstrap public key, you can claim to the device. Exactly the same is applicable here for TLS proof of knowledge when you're doing unwired. If you know the Bootstrap public key, then the network can claim the device. So we're not making any changes to the overall security stance there. We do have working code. There's working TLS stack code that's been up on it's up on GitHub for quite a while now, since before the last IETF. It's built on top of the standard Golang mint stack that that the guys in the TLS working group have done loads of proof of concepts on top of. And this last slide, discussion on next steps. There's 3 general work areas here. One is defining the TLS extensions to transport that Bootstrap key, and that's a pretty small, trivial piece of work. Second is the enhancements to the key schedule to inject that second if we have an exchange into the key schedule. And we're hoping to piggyback on one of the existing drafts, either the Holland one or the hybrid key exchange one. There will be some EAP or TEAP extensions defined and required to leverage define how to leverage that new TLS proof of knowledge handshake. That work still needs to be completed. And we have some general discussion questions here. Well, obviously the first one is there any general interest in this, and the other question is where does this work fit? And we could cover this in one document as it currently is, or do we need to split it into 2 or 3? Like for example, we could have a short draft to define the TLS extensions. And then we could have an EU draft that references those TLS extensions and the Highland key schedule changes. And where does this work? Where does this work lie? Does we start in EMU, move to TLS? Do we have to split some of the work between EMU and TLS? And those are the kind of things we'd like to discuss. And that is it. That's the end of the presentation. It's pretty short. But we feel it's a pretty elegant solution for securely bootstrapping a device onto a wired or Wi-Fi network. And there is working code. Okay, that's it.
I don't see anybody in the queue, but I guess I'll, ask a couple questions. So this is using both a new extension and the Hoyland draft. And so those are 2 pieces that need to be kind of reviewed and worked out. I think right now, I don't think, if I remember correctly, Hoyland isn't a working group item yet.
That's correct. It's not yet. That's correct. It's not yet.
So yeah, and I think there is interest in it, but the working group's kind of been working through some other items, and that hasn't come up again yet. So that's probably something we want to probably talk with Jonathan and other folks and see what their plan is with that draft. And then as far as the extension, I think, certainly I don't know that the extension needs to be done in TLS, especially since like you're going to be using, we'll try, if you're using the Hoyland draft and you're using sort of a standard way to kind of mix things in, that would be reviewed by the TLS group, which would probably be the most concerning part. Yeah, I don't necessarily have too much of an opinion. Do you see use of this outside of DPP and EAP?
Well, the use cases that we're currently targeting, just putting on my Cisco hat at the moment, we're certainly talking to operators, and this is a problem that they need to solve, and they have a serious problem with security onboarding sensors and devices onto wired networks. I see Elliot is in the queue waiting to talk, so I'll actually defer to Elliot to see, do we see use of this outside of EAP?
Hi, good morning, good afternoon, good evening. So clearly there's a pretty clear use case for EAP, but I wouldn't exclude the idea that it might be used elsewhere at a higher layer, right? But that doesn't mean the work couldn't be done in EMU. It just means that we shouldn't write the code, we shouldn't write any extensions that that would exclude the use of EMU, of things other than EMU. Excuse me.
And if I just want to comment, that could influence the shape of the draft as well, and how many drafts we write. And it may make sense to have the TLS extensions in a short separate document so that it's not like bound to an EMU draft, if that makes sense.
So there's Ben in the queue. Go ahead, Ben.
Can Dan get in the queue too?
Sure.
I'll join the
yeah.
queue. Sorry.
Now you're in the queue behind Ben.
Okay, I mean, if you wanted to jump ahead, I don't know what you were talking about.
No, go ahead.
But I guess my question or comment I had started to say in the Jabber room, but it seems like we're using a standard public-private key pair for the bootstrapping keys here. And I was wondering if there's a way that we could be able to use like threshold crypto instead to fulfill the same goals without sort of relying on this weird mechanism where you are not treating the public key as, or sorry, you're treating the public key as something that is not widely distributed. Like it's supposed to be secret as well in some sense. And I don't have a great sense for whether threshold crypto would get around that in any way.
So if I can answer, well, I just see Dan is in the queue as well, but one answer I have is we haven't considered threshold crypto, but we had been looking at complete reuse of the DPP Bootstrap key. So we want, and the Bootstrap key in DPP is a currently defined and published Wi-Fi line standard, and we want to reuse that exactly as is as the Bootstrap key. Now, I don't know whether DPP is any interest in moving to some kind of threshold crypto. I'll defer to Dan on that.
Dan, go ahead.
Okay, thank you. So I'm not sure whether threshold crypto would work, but that said, that's an interesting comment. What I wanted to say was that there's a discussion of using the Hoyle work in TLS to do the extended TLS key schedule, and even if that isn't adopted, something's going to get adopted because TLS needs to deal with the post-quantum crypto issue, and so they're gonna come up with a way to inject random goo into the TLS key schedule, and we can just use whatever that technique is. If it's not the technique that we're specifying now, if the TLS working group decides something else, then we'll just use that.
Definitely, yeah. I considered saying something similar as well, but I think we're all on the same page in that aspect. And thanks to both of you for sort of clarifying the threshold crypto and the wanting to reuse the DPP key point. I had missed that part, so thanks.
Elliot, are you still in the queue? Not anymore. So there was just one comment from Ira McDonald that I guess I should say at the mic. She suggests keeping TLS extension in the TLS working group to ensure review by SMEs. I feel the same. I think our job in EMU will be much simpler once this Jonathan's draft and the extension is adopted by TLS. Then the EMU draft would be very straightforward, and I don't see any issues with progressing this.
Okay, and just for reference, I posted into the chat as well the other draft that we've referenced as the alternative key schedule import, and it's the hybrid design one that has been adopted by TLS. So we looked at both. We implemented what looked like the simplest and most concrete thing at the time 6 months ago, which was the Highland draft.
Okay, I think it would be good to. I think it would help your case in TLS. I don't know how much interest there will be in there for this particular thing. We can certainly check that out on its own. But if this is something that's of interest within, the EMU space, I think that kind of helps the case of working on an extension either in TLS or in this working group.
So there's a question in Jabber. I don't know if Dan or Owen you want to answer. John Frederick asks, will the server still authenticate itself against the client using a certificate, or is the public key of the client the only item that the server uses to authenticate?
As per this draft, the only item that the server will use to authenticate is knowledge of the public key. So if any rogue operator gains knowledge of that Bootstrap public key, then that operator can claim the device onto their network. Now there is, if you read the full DPP draft, the Wi-Fi Alliance DPP spec, it does allow for mutual authentication where you can imprint credentials on both sides. But this draft only does it. This draft here, the TLS proof of knowledge, only does it one way.
Thanks. Hopefully, John Frederick, this answers your question.
Hi, this is Hannes. I was wondering whether you couldn't just reuse the raw public key mechanism out of the box in that case.
So the raw public key, remember it's the client's key, and there's currently no TLS mechanism for a server to prove it knows a client's public key. So if raw public key, if you use a raw public key in TLS, the client is going to send its full raw public key to the server, so it won't work.
Okay,
Does that make
thanks.
sense?
Yeah, we'll have to read the draft, but it sounds interesting. Yeah.
Okay. And you should read the Wi-Fi Alliance DPP spec as well, because that's part of the genesis idea.
Okay, so I think what we would want folks to do is read the draft. So maybe posting it to the list and asking for some review would be good, so that we can see what the interest is in the working group.
I guess this is a question to you, Joe. I don't know if this should be posted to the TLS list, or if this can be presented in the TLS working group at the next IETF. That's something you can consider.
Yeah, I would definitely think should post something to the list and see if we can get some discussion on it. Irregardless of when we would present it in the working group. Dan?
Yeah, I guess you just touched on that. I just wanted to say that it would be nice if we could get a feeling from the group whether this is something that the group wants to address. Can we produce a
we can
a draft IETF draft?
We can do a show of hands right now to see what the interest is. So the interest would be, or the question would be, do folks, is this draft or this topic something EMU should work on?
The closest alternative that EMU is currently working on is Noob, EEP-Noob. This mechanism, as it's currently defined, only goes in one direction. Bootstrap key provisioning only goes in one direction only. But I think the closest analogy is Noob.
Yeah, sure. So I think that I think the question though is we have Noob. Is this a mechanism that people think would be a good topic for EMU to work on? This isn't this is just to get an idea of what people feel at this point in the room. Or did I misunderstand your comment?
So I can answer for Noob. I don't see it competing, so I don't see any reason why we can't have both, because as Owen said, this doesn't do server authentication. You can't do OOB in the other direction where the key is somehow printed or shown on the server and then sent to the peer. So I don't see them competing. I think there is interest, but maybe let's let Joe ask the question to the.
Okay, using the show of hands tool, I'm going to start the thing here. And so if you think this is a topic the group should work on, so there's a raise your hand and there's a do not raise your hand, and then there's, you can, you know, not do anything. So we'll let it go for a little bit.
You seem to have ended it.
So sorry, I must have ended it. I clicked the wrong button. I started it again. All right, I am going to stop it now. Okay, so it seems like there is a fair amount of, is there anybody who, you know, did not raise their hand who has an objection to this work, or who wants to come to the mic? Okay, so there is some interest, so I think that's promising. I mean, I think it's good that it's, you know, kind of bridging the gap between what DPP does and what can be done on Wired. So it definitely seems to me like there could be place for it. So we need to have more discussion on the list, but I think we need to move on to the next presentation. Is my Ling on? I can run the slides if you'd like. My Ling, if you're available. Thought I saw. Thought I saw Myling on the call.
Hello, Chairs.
Oh, hello.
Hello, Chairs. Can you help me to print the pointer from your computer?
Here, I'll.
Yes, thank you very much. Okay. Hello, everyone. I'm Mei Ling Chen. This is my first presentation on the EMU work group. So my draft was first submitted in May this year, and I have sent the emails in the email list for my draft. In this draft, we propose a method of using identity as raw public key in IETF. The core idea is that we use identity-based signatures for authentication instead of just relying on CA certificates. Before we start the whole content introduction of my draft, it's very necessary we have a look on background. PKI-based X509 certificates are very now used in IETF, but still some programs with traditional certificates such as management cost, large certificate chains, and intermediate certificate is not so friendly to the constrained environment devices, such as IoT devices, especially for the weak computing power devices. So I think there are two solutions. One is to simplify the certificate and the intermediate validation process. Another is use a new method for the authentication. Of course, we choose the latter. What's raw public key? In the Owen's presentation, most of us have known the raw public key. That means there is no information other than the public key. For cryptography, semantic secret keys are more lightweight, but the disadvantage is also very obvious, such as the updating operation. So why not try to use asymmetric cryptography? Public and private keys are invoked. What type of data can be used as the public key? That means which we will be chosen as our identity. This is out of scope of my draft, but it's another topic for my research. This draft I propose is based on two other RFC 7250 and 6507. In the RFC 6507 specified an identity-based signature algorithms using elliptic curve cryptography. The mathematical calculation method of signature and verification is provided. And we also noticed that RFC 7250 specified using raw public key with two extensions, makes the raw public key available in TLS and DTLS. Next slide, thanks. Dear Chair, next, yes, thank you. So the whole draft we can divide into three parts. Part 1 is about the structure of the raw public key extension, and part 2 is about IETF 1.2 extends raw public key in authentication procedure, and part 3 is about IETF 1.3 authentication procedure. Next slide, thanks. This is the whole handshake exchange during the IETF authentication procedure. All of us, it should be said, most of us are very familiar about the TLS handshake. The message is started at the client hello. These two extensions is server certificate type and the client certificate type. Server certificate type here means the types of server certificate the client is able to process. The client certificate type means the type of certificate the client can provide to the server. After receiving the client hello, the server will respond with server hello, and these two new extensions also exist here. From the server hello side, the client certificate type indicates the selected type of client certificate type of client certificate, and the extension of server certificate type here indicates the type of certificate in the following certificate load. What's more important is the extension of certificate. We have made some changes to the content compared to what we had before. The certificate contains three major informations. The first one is raw public key. We can also describe it as server identity. The second one is the selected signature, such as ECCSI. The third one is the hash value of the algorithm's public parameters. After receiving the message from the server, the client will verify, and the signature message, self ID, and the public parameters will be the input, and then the peer will verify their signature. If success, the client will also send their own certificate with the same form of the server. After the server verifies the client certificate, it means the mutual authentication complete, and the whole key derivation is also complete. They can transport application data securely from now. Next slide, thanks. The part 3 is we desire IETF 1.3 with identity-based signature. The whole authentication procedure keep the same with IETF 1.2. The core differences between them is just the differences between TLS 1.2 and TLS 1.3. Next slide. This slide is an example for IETF 1.3 version identity-based signature. We can see that in the current hello, there are 3 extensions. Signature algorithm carry the signature algorithms they can use. Under these 2 new extensions, server certificate type and the client certificate type, they can be listed types. And after receiving the client hello, the server hello will respond, and with the same new extensions. The server hello site choose raw public key as their certificate type. What's more, the certificate here will carry the object identity for ECSI. That's the wrong mass value here. And the hash value of the public parameters. And also that's the ID, that's the public key. And also the certificate request will carry ECSI sure 256. That means they want the client side will also use the ECSI sure 256. So after the client received the whole message from the server hello, they will also do the verifier and share their own certificate to their peers. After both multi authentication is complete, the whole TLS handshake finished and send if success to the client. Next slide. So what we will do, we want more discussion. I really think now this version draft is not a perfect one. So comments and co-authors are welcome. And the plan next to do my draft is to apply to the IANA the type code for IETF IBS and defines the key derivation based on IETF IBS. Thanks. So we can start the discussion.
I don't see anyone in the queue.
Anyone have some question?
I have a question. So it looked like in your presentation that you didn't need to do any modifications to the way the TLS flows work, and that you just used the ASM1 definition for the curves that you wanted to use inside the raw public key message. Is that true?
I don't get the key point of your question. Is that mean that I just used this 2 new extensions?
Do you have to create any new extensions or data types within TLS?
Yes, we have. You can, if you're familiar with the RFC 6507, you can know the extension. You can see the extension there.
Okay.
Client certificate type and self-certificate type is really not a new one here. We also have a subject about TLS IBS. We have submitted in the TLS work group there.
Hi, this is Hannes. I was wondering where you plan to use your document, like this specific method, like what deployment environments do you have in mind? Sorry if I missed that.
Oh, I think the most suitable scenario is for the long-lived passive IoT devices.
You said long-lived. Which devices?
Like maybe not very exactly that, but I think the robot machine can use this, especially in the constrained environment for the internet.
So Internet of Things devices. Okay. Mm-hmm.
There's a question in Jabber from Russ Husley. Is this leveraging draft Huang TLS IBE?
Can you you mean the chapter of for Wang Haiguang, right?
So I don't know if I'm pronouncing the name correctly. It's there's a draft that's draft Huang TLS IBE. Is this
Okay,
is your
I got the
draft?
idea.
Is your draft leveraging that?
IBE is a really good thing, but it's much more difficult for me. So I just use IBS here, not encryption here. Just use IBS for the identity authentication, but not use the encryption crypto here.
All right.
We just do like the PKI, the traditional PKI certificates.
Yeah, thanks. Hannes asks, is there some running code for this draft?
Oh, yes. I have in my program, I did the implementation of IETF IBS based on IETF 1.2. We basically implemented the whole process, but it's not open source in the GitHub. It's our internal code, but we can share with the test result.
Okay, I guess, Joe, the next step is like to continue the discussion on the list for this.
Yes, thank you. More comments and discussion I won't see in the mail list. Thank you very much.
All right, next up, I guess, Joe, you will be doing the TEEP errata.
Yeah, so we had a busy time with TEEP errata since the last meeting. I think we had a total of 10 errata published or submitted against TEEP. I think on the list we've resolved 6 of those, and I think 4 of them are really close, and I wanted to kind of go through them today with as many people as we could here. I did get some comments on the list from Oleg, so I know he's looked at them, but I want to make sure that people have looked at them, and if there are any comments today, then we can chat about it. So let's see. The first one we have has to do with the authority ID, which is a TLV, an outer TLV. And currently the draft, the RFC says that this should be mandatory. And the problem there is there's another part of the RFC that says outer TLVs cannot be mandatory. And so the suggested resolution here is to make this optional. Now, realizing that optional means that not everybody has to understand this TLV. And it turns out this TLV is important when you're processing packs. So if you're using packs, you would want to understand this TLV because it helps you to manage them on the client. But if you don't, then it would be optional.
Quick question, Joe, on this one. So
yep.
Is this being made optional because it's an outer TLV and the document says that all outer TLVs are optional?
Correct.
So, this is only needed in the scenario of a pack.
That is my understanding, at least, for the usages. Now, I mean, somebody could define something else that could make use of it as well, but it identifies kind of the AAA server.
Okay, so there are scenarios where TEEP can work without this TLV, in which case this makes sense, making it optional.
But if Elliot or anybody else has any comments. Okay, if not, so Jorge said he agrees with optional. All right, so any additional concerns about making this optional? Okay.
No, looks good.
Move on to the next one. All right. Here, this is one that's a little bit tricky. There are a lot of places in the document where the term EAP method is used, and in a great many of them, it really means EAP authentication method, which is really any method except for the EAP identity method, which does no authentication. So, there's a suggestion to modify this in a couple places, but really it needs to be modified in many places. So my thinking here is that this is something that we would hold for a document update because there's really too many places to update it, just doing it in an errata. And so the errata would be hold for a document update, and we can place a note explaining the reasons why we want to make that change, but the change would be made when we update the document.
So, quick question, what's the EAP identity method?
The EAP identity method is it's a EAP type that can be that the client sends, the server sends an identity request, I believe, and then the client sends an identity response that contains an NAI for routing, typically.
But it's a message type, right? So we have EAP message types, and it can be a request, response, identity, and so wouldn't it make sense to, like, I don't know if the current RFC refers to EAP identity method and maybe just say EAP identity message, or
I'm not sure I follow. Are you saying that EAP identity should not, like EAP identity isn't a method and that we shouldn't, that this doesn't matter? Or are you saying that there's one place where we can make a change? Or?
So what I'm saying is that for me, and hopefully for most other people, I could be wrong, EAP method generally means an EAP authentication method, which was, I guess, the intended meaning when TEEP was written. And I haven't now looked at the TEEP RFC. Maybe I should check it again. But if there are some instances of identity method, it might make sense to like change those to an identity message. Or
yeah, I'm sure that the TEEP spec, I'm pretty sure it does reference the identity method at least a couple times. I think in general, people know what this means, and we're going to clarify some of the other areas where there was confusion between when you send different types of messages. So I think fixing this in multiple other places is not really in scope for an errata. Does anybody else want to comment on this one? All right. So I mean, Mohit, we can take a look and take a look at the TEEP RFC and see if you think there is if there's a simple change to make that isn't like, in 15 different sections, then that might be worthwhile doing. But this is borderline almost an editorial change. It does have some technical meaning in some places.
Yep, makes sense. I'll make sure to look at this. I'm now reading the errata again, so I get some context. Maybe I should have done this before, but you're right. This is just an editorial change, so we can see what's the best way forward.
Yeah. Okay. So the next one, I think, is better to look at in GitHub. So this particular one has to do with how we handle multiple authentication mechanisms, and whether you send an intermediate and when you derive keys and when you do intermediate results and crypto binding. And so the real question was, it didn't really specify whether you did crypto binding after a basic password exchange. It didn't make that clear. And so we've made some modifications here to kind of make it clearer what you do. And so that also, we made sure the procedure for when you don't have a key generated, such as in a password method, what you use in the crypto binding and insert into the key schedule. So this section is just clarifying that. I think this is the main. There's a couple different changes, but this is I went through and kind of what the changes would look like in GitHub, and this is basically saying the 0 MSK is used in the case that when no key is derived, and then the 0 MSK is defined as just an MSK of 32 octets and zeros. And I think there was another section to this change. Let's see now. I think that's it. That's all oh wait here. This is taking a little time, but I think Oleg has gone through this change as well, and it seemed like things are. For some reason, I am not able to open up the other thing right now. But did anybody who's looked at it have any additional comments on the resolution to 5775? Let's see if we can.
So Jorge says he has reviewed the pull request and no additional comments.
Yeah, here's the other change that describes what happens with the intermediate result TLBs that are required after basic password authentication and EAP authentication. And Oleg, I made the change was I think the change was with the next one, basically on what you had requested. All right, so we can move on to the next one, which is again having to do with the intermediate result and password authentication.
Joe, sorry, one comment regarding the previous errata.
Yeah.
So was it decided? It was decided not to introduce the new flag that denotes the only 0 MSK is present, right?
Right. That means
that yeah, sorry.
Go ahead.
That means that there is no technical possibility to use 0 MSK where either MSK or EMSK are allowed technically, right? In other words, if the inner method exports either MSK or EMSK, it must be used, and 0 MSK cannot be used. So usage of 0 MSK is implicitly followed from the specification of the inner method.
Yes.
Maybe we need to mention this explicitly, so it will be clear for the protocol implementators.
Okay. If you could look at, I don't know if that would fall in this errata or one of the other ones, but if there's a sentence we could add, maybe even in this one, we should look to see where we could add that. Maybe even in this table, which I think maybe was edited in another pull request.
Also, the good
Yeah.
place is section 5.2.
Yeah.
Oh, it is.
Yeah, that's where we are. So if you could take a look at I think that could be a fine idea if it's just an addition in one of the current errata, which I think it could fit into. That would be good, because I think the intention is that if a method generates an MSK, that it should be used. So I don't think it would be worth time to fix this here, but we can go offline and work through what the change would be. Thanks.
Okay.
Okay, then 5844. This is another one with several parts to it. This is just again, oh, I didn't want to do that. Just again, kind of clarifying some of the appendices to include places where there was a missing crypto binding TLV and intermediate, or I think the crypto binding TLV. Seems like maybe this isn't correct. Oh yeah, no, the crypto binding TLV is right here. To clarify that you need an intermediate result. So I think these were errors in the specification. I think it's pretty straightforward for this particular change. And in this case, the other changes resulting from this errata are almost there. I'm just going to try to get these going. GitHub is not responding quickly to me today. Okay, let's see. Again, so looking at this change, this is again clarifying that intermediate result TLV goes after authentication methods and basic password authentication methods. Pretty straightforward. And this is where I clarified the text based on Oleg's comment that an intermediate result indicating success must always be accompanied by a crypto binding TLV. This is discussed elsewhere in the document, but just to make it crystal clear, we included it here as well. Is that clearer, Oleg?
Yes, it looks clear.
Thank you. All right, let's one more spot. And again, instead of just talking about individual EAP methods. We talk about authentication methods and password authentication as well. So are there any other comments on these errata or any of the other errata that we didn't discuss yet? I think we still have one open issue, which Oleg brought up, which I think that'll be pretty quick to resolve. But I'd like to try to wrap these up and send them to Roman so he can figure out how we take this to the next.
Jorge, you're up next. Go ahead.
Yep.
I apologize. I sent an email to the list just right before this meeting, so I doubt anybody has had time to review it and think about it. But errata 5768, the current proposal is to, it involves the HMAC, and HMACs have different lengths depending on the algorithm used. And so it relates to changing the length in the crypto binding TLV to be variable based on the type of HMAC used, which sounds good to me, but I do have some compatibility concerns because the existing document says the crypto binding TLV, the length of that field is 20, and existing implementations use that length of 20, and they truncate any output that is longer than 20. They truncate it to 20 octets. So I agree that the direction of making that variable is good, but I'm concerned it has compatibility impact, and so perhaps to make that change, we would have to increase the version of the crypto binding TLV.
Yeah. So then if existing, I think if we're going to increase the version of the crypto binding TLV, that's like a document update. And what we could do in the errata is clarify what the existing behavior is. I mean, if existing implementations are doing, you know, SHA or SHA-256 and then truncating it to 20 bytes, and those are existing implementations, that might be what the errata should say. And then in a document update, we can add a new TLV that, you know, create a new version of the crypto binding TLV.
I agree with that path forward, and we can clarify what the existing implementations are doing on the list. I suppose I just wanted to raise that concern here. Thank you.
Yeah, it would be awesome to get the make sure that this is what implementations are doing, and then if they are doing this, then that's probably the best path forward.
Elliot, you're next.
Hey, thanks very much. This is just a weird IETF because I'm trying to follow two rooms at once. I'm supposed to speak in another. First, Joe and Jorge and Oleg, thank you for all of your work on this. And it was a lot of work, and it took a lot of effort to just get slog through all these. And a thanks to Yoni, even though he's not here. First, I agree with the last point that that one should be hold for update. But the reason I got on the microphone was to say, and now that we're getting through these, I want to unstick the TEEP update. I didn't think we should start that until we slogged through these. I think that was the general sense. I think you said a meeting or two ago that was the general sense of the working group, that we should slog through these and then do the TEEP update. And so now that we've done that, I'll unstick that draft, but I think we're probably going to rewrite it from what was a sort of a Brewski-oriented draft to more of just a TEEP update draft with a couple extra TLVs. And what I'd like to do is invite you know, Jorge and Yoni and others to really work with me on that, so that as we go through, we can make sure that all of the errata get properly incorporated in, that we're making sure that we're comfortable with TLS 1.3. There are a couple of authors on the draft already. Dan Harkins is on it. I think Owen is on it, and a couple of others. we'll probably want to incorporate a few other things to make sure, for instance, that the poke work is incorporated depending on, or that we can easily update on top of the update, as it were, with a separate draft for poke, and we can make some decisions about that depending on timing. So again, thanks for all the work. It was a lot of work, and I personally appreciate it.
Great. Yeah, it'll be good to kind of get a revision going, I think, especially now that we have implementations. I think this experience with TEEP really solidifies. I think the areas where we had most of the problems are areas which did not receive as much implementation at the time, and so implementation is key when we're working through these issues.
Absolutely. So again, that you're absolutely right. There has to be code. Totally agree.
All right. I think there are a couple items to take. So Jorge, thanks for raising that issue, and we will take a look at what's on the list, make sure our implementations are aligned. And I think there's one other kind of more editorial change we could make to one of the erratas, but I think that'll help understandability. So awesome. We're almost, I see the light at the end of the tunnel. Roman, is there any other information like that you will need? I mean, I can work with you on what format is best for you and how we need to split these up or whatnot. But is there anything you think we need from the working group at this time?
No, all I can really do is reiterate the things that Elliot said. What's happening here is phenomenal. I love the process kind of with GitHub, kind of on the clarity. For every other working group I have, no one works the errata so consistently as this. So this is a tremendous amount of help. I don't really need anything more other than I may have kind of occasional questions when I personally drop it into the interface, but it looks like you have all the necessary things, and everyone, we've walked it through the working group to make sure that we're all on the same page. So this is phenomenal. And when you say you're done, I mean, I'll start dropping it into the errata interface. Thank you. Really, again, this is
awesome.
Phenomenal.
Okay, cool. All right, so I think we're done with this for the time being, and I think the next thing was an update, some updates on EEP-NOOB. Do you want to? Are you giving those, Mohit?
Yeah. If you can share the slides, that would be great. Elliot, by the way, are you still on the queue or just accidental? Yeah. So yeah, hi, this is a short update on EEP-NOOB. I think by now people are familiar with what this method does. So next slide, please. Yeah, generic authentication framework, and there's no methods that do OB authentication. So yeah, this is a new method for doing that. Next slide. It basically does uses a user-assisted out-of-band authentication in either direction, whether it's from the peer to the server or from the server to the peer, and supports basically any type of OOB channel, whether it's QR code, sendef tag, audio, blinking LEDs, and so on. And the user doesn't have to perform this step every time because we have this fast re-authentication where previously registered devices can get fresh keys without further user interaction. Next slide. So this is the rather long timeline of EEP-NOOB, but it seems we are getting towards the end, and hopefully there's light at the end of the tunnel. So it has been around for a while. There are several implementations. We adopted it as a working group item in earlier this year, and like the draft already was stable when it was adopted, and now like we got like reviews from Hannes, from the IoT Directorate, from Security Directorate, and basically the working group versions have been updating the draft based on these reviews. So now we are at working group version 2. So that's the stage we are currently at. Next slide. At least we, the authors, believe that it's ready. There's 3 implementations, two of them in WPS applicant and host APD, and 1 in Contiki. There's formal models in MCRL2, which is basically for checking the state machines and DOS resistance, and ProVerif to verify the security goals. So the difference between the 2 implementations in supplicant host APD, the first one is more feature rich. So it does all sorts of things like NFC from peer to server and server to peer, whereas the third implementation on this bullet list is, I would say, more streamlined and stable and less feature rich. So it's, I would say, like less bugs and less features and more stable implementation, which was completely rewritten earlier this year after the draft was working group adopted. So the first implementation was done mostly by us, the authors, whereas the second and third have been done by other folks. Next slide. So updates since the last IETF, we have been receiving like private emails, basically asking questions or opening issues on GitHub. So we got like an email from Miguel at Analog Devices, and they are working on an internal proof of concept of EAP Noob. And basically, we received some questions on how to set up the implementation. And there were some minor issues with the reconnect exchange, not in the spec, but mostly in the implementation. So what was happening that the reconnect exchange was not triggered in the state machine at the right time, and this caused the reconnect exchange to fail. And Miguel from Analog Devices then actually sent the pull requests to the implementation. There's several others. I'm not sure if they want to be named here and listed here. Some, of course, are university projects, which are obviously nice, but maybe some of these POC implementations in various companies sound more interesting and have more like interesting use cases where, for example, one of the emails that we, the authors, got was that the deployment scenario is we come with our own access point and then configure the devices and then take away the access point and transfer the devices to a different access point at the customer side, which I thought was interesting. And it seems that thanks to EAP in framework in general, we don't have issues with these kind of scenarios where the access point, there is a temporary access point for configuring, but then the devices join the actual access point on site. Next slide. So the only remaining issue I think that has now been on the table was basically doing CBOR versus JSON. And this came up in Dave Thaler's directorate review, and as well as Michael Richardson, who was saying whether we should move to CBOR. And we realized that CBOR is going to be a major change at this stage. And of course, we could do simple mapping of JSON to CBOR, but that doesn't really get you the gains that you would get from like doing native CBOR and doing the entire specification in CDDL. And since we are seeing some of these deployments that are creeping up at this stage, maybe it's fine to just stick with JSON and let this go through. And of course, EAP-NOOB has secure version negotiation, so you can perhaps think of a future version of EAP-NOOB which supports CBOR. Although I think we will have a presentation after this on EAP-ADOC, which perhaps is more suitable for the extremely constrained devices where CBOR is more likely to be a necessity rather than the case of EAP-NOOB. So for now, given that we have these deployments coming up, I'm a bit concerned that moving this to CBOR is not worth the benefits. And I mean, if there are strong requests in the future, this can be done. But at this stage, it feels like the really constrained devices may prefer than to go with EAP ad hoc, for example. Next slide. And hopefully this is my last slide. So we have had early reviews from IoT and Security Directorate. We got IANA okay with the current request, whether it's for the method type or the special domain name. And I would like to thank Wes Hardiker from the IAB, who kind of did the hand holding and explained the process. And it's nice that IANA can do these early reviews to confirm and weed out any issues in the IANA request section. So the authors believe it's ready for last call. If there are any comments, I'm happy to answer.
In particular, I'm interested in anybody has any strong feelings about just keeping everything in JSON. It sounds to me like that's a good way forward, but just want to make sure that we don't have any strong objection to that.
I don't see anyone at the queue, so maybe Joe, if you can do the last call, then I'm sure we will have some other issues to sort out when the reviews come in from other directorates during the last call. But unless there is something major, we could start the last working group last call.
Yeah, I think that's a good idea.
All right, I think we are doing great on our time. So next is ad hoc. Hi, Eduardo.
Hi, can you hear me?
Yes, we can. Go ahead.
Great, thank you. Well, thank you for having me today. I am Eduardo Ingles, and I'm going to present this draft published with Dan Garcia and Rafa Marin. The draft includes the initial idea of the new method for EAP based on ad hoc authentication protocol. Next slide, please. Our goal is to design an alternative EAP solution for constrained devices using ad hoc. ad hoc is a protocol that is currently under development at the Lake Working Group. And in this working group, they intend to produce a lightweight authenticated key exchange for OSCORE usage. And they use the CBOR protocol and recommend the use of co-op to transport messages. They also want to provide end-to-end protections. If you need more information, you can check the drafts and the working group. Next slide, please. In this first version of the draft, we established that the peer acts as an ad hoc initiator and the server acts with the role of a responder. So on that basis, the message exchange for the EAP method starts with request and response identity. Then the authenticator sends an ad hoc start message with no data. And at this point, since the peer is the initiator, it starts the ad hoc exchange by sending the 3 corresponding messages and ends with an EAP success or failure message. Next slide.
Can I ask a question here?
Of course.
So, now that I see this orange message, isn't it like ad hoc is a 3-message protocol, but now we have the 4th message, and you might be able to get rid of this extra message by just making the server as the initiator. Is there Like, I'm wondering, is there any reason not to do that?
Yeah, that's a great question. Actually, we have that in mind. We wanted to plan this question here. There are two options, of course. We can use the server as the initiator. So the fourth message will be a message with data. We will have to define it correctly. But of course, yes, we can do it starting with the server as the initiator.
And we have John in the queue. Go ahead, John.
Yeah, there are some privacy implication by changing who sends message one. So in ad hoc and all the similar protocols like TLS 109 and so on, you get so in this message flow, the server will send its identity to basically anybody asking, sending ad hoc message one. So if you return, so you get active protection of the ERP peer's identity in this message flow, and only passive protection of the server's identity. If you reverse the order, you get stronger protection of the server's identity and weaker of the peer.
That makes sense. So yeah, in that case, I think the current message flow is fine. Yeah, I think it's better to protect the privacy of the peer. So yeah.
Yes, actually, that's why we started including this version instead of including the other option. But I mean, I don't know any use case that we really need to put the server as the initiator. But maybe someone else has another use case.
Yep, thanks. I guess.
Okay,
yeah.
Thank you. So next slide. Okay, thank you. So EDOC allows to define which protocol is responsible for ensuring the correlation of messages. So EDOC itself or the protocol, or the transport protocol, sorry. In this case, the IP protocol is based on the lockstep procedure and guarantees the ordering of messages. Therefore, EDOC doesn't need to use its internal mechanism for correlating messages. That means that we set the variable core to the fixed value 3. Next slide. So my intention in this presentation is to actually present the idea to the community to get your feedback. And our next steps are to add the feedback received, continue adding the protocol details, and work on making the design compatible with this draft based on IP for radios. Next slide, please. And to end this presentation, I would be pleased to hear from the participants whether they think this draft makes sense as a working group item or not. And please be welcome for any other comments. Thank you.
John, are you still in the queue?
No.
Okay. So I can say as an individual participant, maybe at some point. Why not? Right now, I think it's maybe a little bit too early, but perhaps when ad hoc is perhaps a little bit, I don't know, maybe one more IETF cycle and maybe ad hoc is almost done, and then we can go start deploying ad hoc in these other protocols. But doing that right now, maybe, I don't know, at least personally, I feel it might be just slightly early, but maybe others have differing opinions.
Okay, thank you.
John, go ahead.
I think I support this draft. I think it may be a bit too early to adopt it. Ad hoc is now adopted by Lake, but which means that EMU could work on it in parallel, but there is no hurry. It would still have to wait until Lake publishes ad hoc.
Okay. Well, I guess that's all. Thank you for your comments. And I think so far I will continue working on parallel, but of course I understand your opinion, Mohit, that still there are many changes to be done on ad hoc. So I will take that into account.
Yep, I guess, Joe, the next step is to continue the discussion on this draft on EMU and Lake whenever needed, if there is some requirements that EAP ad hoc requires from ad hoc and the Lake working group. Then, of course, it should not wait for ad hoc to finish, but perhaps we can revisit this next IETF.
Yeah, I think that makes sense to kind of, just let ad hoc kind of go through a cycle at least to kind of get it a little more stable, and then we'll see if any additional issues pop out of that, and then we can start thinking about adoption.
Okay, thank you.
All right, I think that is the end of our agenda.
Yep, indeed. We seem to be 20 minutes ahead of time. Does anyone have some comments before we close the meeting?
Any words of wisdom before we part? All right, well, I guess we'll see you at IETF 110, or perhaps at some interim meeting between then.
Yeah, I would just like to thank Roman for taking the notes. Thank you, Roman.
Yeah, thanks.
It was only me in the beginning. Others helped for the rest of it. I only got the first 2 sessions, so only a little bit of credit. Thank you.
You broke the ice, though, so. All right. We'll see you in Gathertown or somewhere else.
Bye.
Bye-bye. Bye.